Hi guys. Today we're starting our last new section for this chapter. We are going to spend 2 days on this section today and tomorrow. And then later this week we have a quiz and our test is next week on Friday. All right, so for this last section, we're going to continue with roots and radicals, but we're going to do something a little bit different. So in our previous sections, we were doing expressions, which are problems that you simplify, but today we're going to be doing equations, which is something that has an equal sign and something where you're trying to solve for x. So in today and tomorrow's videos, we're going to be solving for x. We're going to get like x equals 5 or something like that. For today's videos, we're going to focus on radical equations like this. When you're writing these equations, it's important that you are very careful with your signs and your symbols and that you are very precise. In this problem, I'm taking the square root of 4x plus 1. Notice how the square root sign goes all the way over the 1. But also notice that the square root sign does not include the negative 5. The negative 5 is outside the square root sign. That's important. Numbers that are not caught underneath the radical can be moved to the other side of the equal sign, and numbers that are trapped inside the radical cannot be moved. So in this problem, I'm going to start by moving that minus 5 to the other side. Once you get the radical all by itself, you're going to do the inverse operation, the opposite. The opposite of a square root is squaring. So I'm going to square both sides. And on the left side where the radical was, the square and the square root will cancel out, leaving me with just the inside numbers. From here, I hope you guys know how to solve this. And we get x equals 6. Okay, so get the rad by itself, then get rid of the rad, and solve as per usual. Once you've solved, it's important that you check your answer. Make sure that it works back in the original problem. So I'm going to take my 6. I'm going to plug it back in up here to my x. When you're solving, you have to simplify the inside of the radical down to a single number before you can actually take the square roots. So 4 times 6 is 24. 24 plus 1 is 25. And now that I have a single number underneath my radical, now I can take the square root of that number. And it turns out that this problem does work, so we did a good job. Let's try another. Now, in this problem, it's going to get a little bit trickier because I don't have just numbers outside of my radicals. I also have a variable. So this one's going to be a little bit more intense. Well, we're going to start the same way that we did our last problem, which is we're going to take this plus 3 that is not trapped under the radical sign. We're going to move it to the other side by subtracting it. At this point in time, I'm going to square both sides. Now, when I square the right-hand side, I need to square the entire thing as one quantity. So I need to do x minus 3 squared. When you do x minus 3 squared, it's not just distribute the square into the parentheses. You do want to actually write out x minus 3 and another x minus 3 and multiply that out. If you just distribute the square, you're going to be missing your middle term, this minus 6x, and then you're going to get the problem wrong. So make sure that you are distributing the square. When we have an equation with an x squared in it, we need to make it equal to 0 so that we can then use one of our methods for solving. Like we can solve by factoring, we can solve by quadratic formula. We could do completing the square, but probably don't want to do that one. If you really wanted to do, we could do the stuff that we learned in chapter 5, but I'm pretty sure most of these are going to be factorable. So we're going to set this equal to 0, and then we're going to factor. In this problem, I'm going to factor using Xbox, actually just the X from Xbox. So two numbers that multiply to 10 and add to negative 11, and that would be negative 10 and negative 1. Don't forget, those are not your answers. That's what goes inside the parentheses. To get your actual answer, you'll have to move it to the other side, which will change them into positive numbers. So I think my answers are positive 10 and positive 1. But I do have to check. It's especially important to check your answers when you have a variable that's not underneath the radical. When that happens, it is possible to get an answer that's not really an answer. So let's check. When you're checking, you're going to plug one number in at a time, and you're going to plug it into all of the x's. So I started with the number 1. So I plugged that into this x over here and this x over here. Remember, underneath the radical, you need to simplify it down to a single number before you can square root it. And I get that the number 1 does not work. When I plugged it back in, it did not give me a true statement. That means that 1 is not an actual solution to this problem. It is called an extraneous answer. So if you were writing out the solutions to this problem, you would not include the number 1. Even though we got the number 1 when we solved it, it's not a real answer. Now, sometimes the question wants you to list the extraneous solutions. So sometimes they actually want to know what's the number that doesn't work, okay? So you got to read the directions very carefully. But again, 1 is not technically an answer to this problem, even though we got it when we solved it. When we plugged it back in, it doesn't work, and that is called extraneous. Now, it is possible that both of them won't work, so we should plug the number 10 in as well, check and see if that one works. It's also possible that they both do work. So sometimes you'll get 2 answers and both of them will work and you'll have no extraneous solutions. Sometimes both of them are extraneous solutions. So that's why it's really important for us to check. All right, so 10 did work, and that means that the only answer to this question is the number 10. Why don't you guys try this one on your own, see how you do, and then check back when you're ready. All right, so this problem was very similar to the example we just did. You are going to have to do some factoring. You're going to get 2 answers. But just like on the example we just did, one of them doesn't work. One of them is extraneous. So the answer to this problem is 9. And if I wanted to know what the extraneous solution was, the extraneous solution is the number 2. This concludes our first video for today.